Now let's look at these coefficients and interpret them. Remember, we are not interested in intercept, only the slope coefficients. The slope for square footage is 56.43. Okay, see, we can use this kind of formula to get the coefficients displayed here. So it's concatenation. So start with an equal to, otherwise this will not be a formula. And then I have B sub 1 within quotation marks, and then I have an ampersand, and then I have the round and that cell address. Okay. Now the first coefficient is about square footage. So remember, all the slope coefficients relate back to y hat. Y hat here being the price of the house. Okay. Now the square footage here says that if the square footage increases by 1 unit, then y will increase by that much. Y being the price of the house, then each square footage, each unit of y square footage is worth $56.43. The house price will go up by that amount. And when we are talking about multiple regression, you have to add one more caveat to the interpretation, and that is all other variables remaining the same. Okay, when we alter just that one variable, this is what will happen. So the selling price is estimated to increase by that amount for each additional square footage, with all other variables being the same. Now B sub 2 is about age. So here we have a negative coefficient. So that means if age goes up by 1 for each additional year of age, the price of the house will decline by 3,962, with all other variables remaining the same. Okay. The selling price is estimated to decrease by 3,962.82. Okay. The selling price is estimated to decrease by that amount for each additional year of age, with all other variables being the same. Now B sub 3 is condition excellent, B sub 4 is condition mint. And here is where the variable that got left out for defining dummy variables, remember we have 3 categories, so we defined 2 dummy variables. So the interpretation of these coefficients is going to depend upon, the baseline is the condition that was left out. The condition that was left out was good. So compared to good, what condition excellent will get for you in terms of house price. So that's what this coefficient is. So compared to a house in good condition, a house in excellent condition will fetch $33,162 more, with all other variables being the same. Okay, so compared to good. So that's you have to, when the variable that gets left out, okay, is used in interpreting the dummy variables. The condition that gets left out is used to interpret the dummy variable coefficients. So same here. Compared to a house that is in good condition, a house that is in mint condition will fetch that amount of dollars more in price, with the other variables, the age and square footage, being the same. Now let's look at estimating y. The estimating equation is that, okay, so these variables. All right, so let's look at how we're going to use this equation to estimate house price. So what is the estimated selling price of a 20-year-old house? So age is 20, so we put 20 there. Okay, square footage is 2,500. Okay, right, mint condition. So mint condition means x sub 3 is 0, x sub 4 is 1. All right, then our y hat will be, so y hat is that plus x sub 1 you put 2,500, x sub 2 you put 20, x sub 3 is 0, x sub 4 is 1. So you get, all right, intercept plus we can do a sum product of these coefficients with these values, and that will give us our estimate. Let's make it into currency and not decimal places. So that's our estimate.